we're going to push beyond only using matrices to solve systems of equations, and instead we're going to start considering matrices as their own objects and seeing what we can do with them. And so this video is going to go over some of the standard operations that you can do with a matrix. The first one is called scalar multiplication, and this is when we're going to go ahead and multiply a matrix times a number. Now I've given you an A, B, and C just so we have some matrices to use in our examples here. So let's suppose I started by trying to do 5 times A. We would do 5 times the matrix 1, 2, 3, 4. And it turns out that the way you multiply a number times a matrix is exactly the way you'd expect. You just distribute that number in. So 5 times 1, 5 times 2, 5 times 3, and 5 times 4. And that would give you the answer. So scalar multiplication is pretty straightforward with regards to matrices. The next is matrix addition and subtraction. This is also relatively straightforward. Suppose we want to do A plus B here. We write down our two matrices, and then we want to add them. We just add up corresponding elements. So for example, upper left plus upper left, 1 plus 5 gives me 6. Adding upper rights, 2 plus 6 is 8, 3 plus 7 is 10, and 4 plus 8 is 12, and that would be the answer. We could also have done something like 2a minus 3b. I'm not going to work that out, but it's the same idea. You distribute your numbers over the matrices, and then you can just subtract the elements. There is one thing I want to point out here. If I tried to do a plus c, then I would have the following here: 1, 2, 3, 4, plus 5, 6, 7, 8, 9, 10. And the thing is, when I start trying to add them up here, I notice that I have 4 different numbers in A, but 6 of them in C. And the question is, how am I going to line them up to add which ones with which ones? It turns out we simply will not even try, and we will call this undefined. So that means that you can only add matrices or subtract them when they have the same size, the same number of elements in them. And if they're different, then you literally just throw up your hand, say I can't do it, undefined. The third one here is called the transpose, and that's when you put this little t where you would expect an exponent to be. And what that means is you switch what the rows and columns are. So right now my first row is 1, 2. That's no longer going to be the first row, that's going to be the first column. And similarly, 3, 4 was the second row, it's now going to become the second column. Now let's see what happens when we have a matrix that's not a square. So let's just say C, which was 5, 6, 7, 8, 9, 10. If I transpose that, the first row becomes the first column, which means I'm going to have 5, 6, 7 down here, and then the 8, 9, 10 across becomes 8, 9, 10 down. And notice how the original matrix C was a 2 by 3 matrix, and when we transpose it, it becomes a 3 by 2 matrix. So just got to be careful when you're doing your transposes here. And the last thing, this is the most complicated of these operations, and that's called matrix multiplication. That's when we're multiplying matrices together. And what you might think is you might say, well, okay, let's just multiply the corresponding elements together just like we added them before. Turns out, nope, that's not the way we want to do this. It's not going to work at all for us. It's a much more complicated procedure. So here's what's going to happen. You're going to take rows in the first matrix, and you're going to take columns in the second matrix. And if I combine the first row and the first column, then overall, that is going to give me the answer that is in the first row and the first column of the answer. And if I take the second row and first column, then that answer is going to be in the second row, first column of the matrix. And if I take the first row and the second column, the answer would be in the first row, second column of that. And finally, if I take the fourth row, or sorry, the last row and the last column, it's going to be right there. Oops. And so what do we do with these things here? We take the numbers 1, 2, we take the numbers 5, 7, and we're going to do the following here. We're going to do 1 times 5 plus 2 times 7. And if you work that out, it's going to be 5 plus 14 is 19. And I'll actually just make that red so we remember where it came from. Then when I'm going to do my purple one here, that was where I had 3, 4, and 5, 7. I would do 3 times 5 plus 4 times 7 is 15 plus 28 is 43. Then for my green one here, I'd have 1, 2, and 6, 8. 1 times 6 plus 2 times 8. And it's always plus between these, okay? If you have negative numbers, you're adding a negative, sure, but you always put a plus sign between these. And then, let's see, 6 plus 16 is going to be 22. And then the last one here is where I have 3, 4, and 6, 8. 3 times 6 plus 4 times 8, 32, 42, 50. And so this big mess over here, this would be the answer that we are looking for A times B. Couple of things here. First off, I want to point out that if you had multiplied B times A, you are in fact not going to get the same answer as A times B. You are used to, in everyday life, when you multiply numbers together, say 7 times 2, you get the same answer if you did 2 times 7. That's what's called commutative. But it turns out that when you're multiplying matrices, it is not commutative. You are generally going to get a different answer. So be very aware of which matrix you're putting first and which one you're doing rows and columns on. Always the left one you're doing rows and the right one you're doing columns when you're doing this multiplication. Also, if you had something like A times C, and you think about doing rows and columns, that's actually going to be possible. And so it turns out that when you're looking at the size of the matrices, 2 by 2 and 2 by 3, as long as these middle two numbers are the same, you're going to be able to do this process. So A times C, this will have an answer. But if you did C times A, then if you check those middle numbers there, you would have 2 by 3 and 2 by 2. These no longer match, and this is why if you take a row here and a column here, they don't have the same numbers. This would be undefined. So definitely matrix multiplication is the most involved of these operations. I absolutely would recommend you practice, like a dozen of these matrix multiplication here to get the hang of it. And once you do get the hang of it, it can go pretty quickly, but at first it's going to take a long time. So just stick with it, and eventually you'll get it working out.